Hello, and welcome to Calculus Lesson 33. Today, we are going to be playing with the general idea of graphing polynomial functions. So, what's the idea? They're going to give you a function. So in this case, we have quite the ugly one. F of x equals x plus 4 times x plus 2 to the fourth times x squared plus 3, that's gross, x minus 5 cubed, x minus 7 squared. They want to know, well, what is this going to look like? What is this function going to look like? Well, it looks like we have x times x to the fourth times x squared times x cubed times x squared. That term is going to take over generally. So if I were to multiply that out, that's 1 plus 4 is 5, 6, 7, 8, 9, 10, 11, 12. So it's x to the 12th plus a bunch of stuff. Now what is x to the 12th going to look like? Well, we expect some sort of function that honestly looks like a parabola, but has more turns than that. So y equals x is simply a line. Y equals x squared is a parabola with one turn, one less than the power. Y equals x cubed has two turning points. Y equals x to the fourth has three turning points. Actually, this function is super flat, but if you add other terms to it, you get those. Y equals x to the fifth is going to look like this. 1, 2, 3, 4, 5. So if we go to x to the 12th, well, we probably assume that it's going to look something like this. With 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 turns to it. It's a little crazy. You can also find the zeros if you wanted to. You could also find the end behavior to check your work. But the idea of this lesson is they want you to identify which graph goes with which curve. So you're going to use end behavior. Remember, end behavior is when you take the limit as x approaches infinity or negative infinity of your function. And that tells you what it should do at the very ends. And you can use zeros to determine what the graph will look like. Now, my friends, unfortunately, there's not a lot of example problems. That is lesson 33.